Okay, so remember there are three cases when you want to use trig substitution. And the first one is, so it's three different kinds of square roots. First one is when you have the case x squared minus a squared. And when that's the case, you're going to use a substitution x equals secant theta. Sorry, x equals a secant theta. Second case is when you have square root of a squared minus x squared. And in that case, you're going to let x equal to a sine theta. And then the third case is when you have the square root of x squared plus a squared, or a squared plus x squared. And in that case, you're going to let x equal to a tangent theta. And the steps are basically what you want to do is you're going to substitute based on the which one of these three cases you have. You're going to substitute to get rid of the root. And then the second step is to evaluate the integral. And then the third step is to go back to the original variable. So that's a quick little recap of trig substitution. Let's do an example. Okay, so we have our integral here, and we recognize that it's of the case square root of a squared minus x squared, where a is equal to 2 in this case. So then that tells us what our substitution is going to be. That means that we're going to do x, we're going to let x equal to 2 sine theta. Okay, so then you need a couple of things, and you need to find what dx is, because you're going to have to substitute that. So that's dx is going to equal to 2 cosine theta d theta. And then you need to get rid of the square root. So you go, okay, so square root of 4 minus x squared. If you plug what x is equal to into there, you get the square root of 4 minus, if you plug 2 sine theta into there, you would get 4 sine of theta, sine squared theta. Okay, and so then this is equal to the square root, and then I need to get rid of the constant, whatever that is. In this case, it's 4, so this is 1 minus sine squared once I factor it. And then you break up the root, and so this is going to equal to 2 times the square root of 1 minus sine squared theta. Okay, and then you go, well, I know what that is. Using the Pythagorean identity, this is just cosine theta. So what you get is that the square root of 4 minus x squared is simply 2 cosine theta. So this right here is 2 cosine theta. And then dx is going to be, you're going to replace it with 2 cosine theta d theta. Okay, so then what I get is that this integral is equal to, I'm going to put it over here, is equal to the integral of 2 cosine theta, and then dx, which is another 2 cosine theta d theta. Okay, and so let me take the 2's outside. That's going to be 4 times the integral. Now, cosine squared, to be able to evaluate that, remember that, where can I write this? Let me go down. Tiny bit here. Okay, so remember that cosine squared is equal to 1/2 times 1 plus cosine of 2 theta. Okay, so that's a trig identity that you should know. So this cosine squared, I'm going to replace it with this. So this is going to be 4, and I'm just going to put the 1/2 over here on the outside. So this is going to be 1 plus cosine of 2 theta d theta. Okay, and then if I find the antiderivative of this, I would get 2. The antiderivative of 1 is theta, and then plus the antiderivative of cosine of 2 theta is sine of 2 theta over 2. So that gets rid of these, and then plus c, of course. Okay, so then you have to go back to the original variable. So then you go, okay, so you need to find what theta is with respect to the original variable, which is x, and you need to find what sine of 2 theta is. Okay, now you don't really want sine of 2 theta there, because it's going to make it harder to find. So let's rewrite this. Let's use the trig identity for sine of 2 theta. Let's write this as sine 2 sine theta cosine theta. Okay. So let's go back here. So what we have is, we know that from this, oh, yellow is not a good color. Okay, so I know that x over 2 is equal to sine of theta. So that means that theta is equal to inverse sine of x over 2. Okay, so that's that part. So this is equal to 2 times inverse sine of x over 2. Okay, now to find sine of theta and cosine theta, what we're going to do is we're going to use this. We're going to make a right triangle with this information right here. So since sine of theta is equal to x over 2, let me make my right triangle over here. So I have my right triangle, and then let's say that theta is right here, so then this is going to be x over 2. And so using the Pythagorean theorem, this is going to be square root of 4 minus x squared. Okay, and so then what you get is you can easily find these. So sine of theta is, we already know that one, that's just x over 2, right? Sine of theta is x over 2. And then cosine of theta is going to be simply square root of 4 minus x squared over 2. And then plus c. And that's it. You can simplify it a little bit more, but we'll just leave it like that.